Hi everybody, hope all is well. I had to do some projects for work and I had to clear the bench off temporarily. So I took the realistic STA 2080 off the bench and put it back together. Of course it's fully functional now, but it does need to be recapped. And I will eventually do that, and I'll probably do a small video on that. And of course we've not done any testing on it at all to kind of look at how it performs. So I'll do that in a later video, but I kind of felt like putting something different up on the bench that's a little more challenging. Just kind of felt like it after coming back from vacation and everything. So I have this Marantz model 2252B, and it came in, and to my knowledge, if I recall correctly, when this came in, I was told that it doesn't work, that it has multiple problems. And when I got it, there's just a couple buttons missing. It looks pretty clean. The AM antenna must have broken off because it's on backwards. So I'll have to take it off and put it on the right way. When this showed up, it only had 2 screws in the cover, and they weren't even screwed in the whole way. They were just kind of finger tight on the side, and all the rest of the covers are missing. So, indicating that probably somebody worked on this thing at some point in time. So what we're going to do is I'm first going to take the cover off and just see if somebody disconnected anything or messed with it, or if there's anything obvious, and then I'll try to power it up. But I'm kind of hoping this has issues because I'm really in the mood for doing some troubleshooting. If this turns out to be a problematic receiver, I think I'm going to do something a little different this video. I am going to only use one piece of test equipment for this video, and then when we do part 2, we'll use another piece of test equipment. We're going to try to see how far you can get with just the minimal test equipment. So the only thing I'm going to use in this video is going to be a multimeter. Now this is a fluke, and everybody's going to say, well, it's a $400, $500 meter. It doesn't matter. You can buy the $39 meter on eBay. It has most, if not all, of these same features on it. It's just a less expensive meter, not quite built as sturdy as these or whatever. So we're just going to see if we can use a standard multimeter and how far we can get without any signal generators, oscilloscopes, any of those things, distortion meters, nothing. We're not going to use anything but the most basic things. We're going to use just a dim bulb tester. I showed you in previous videos how to take an extension cord and how to make just a very low cost dim bulb tester. I'm just going to use the one on the bench because it's essentially the same thing, just mounted to my bench. That's light bulb in line with the with the power cord. So that's what we're going to do in this video. Let's see where we are. Okay, let's take our only 2 almost not in screws out. And let me put these in a container because of course we don't want to lose our 2 screws. And again, this is untouched, and how it came in, I've never taken it apart or anything like that until now. And you can see the antenna is definitely something's not right here, but we'll fix that. Nothing seems to be, at least on the surface here, nothing seems to be tampered with a whole lot. So why the cover screws are missing and everything, I don't know. Let's flip it up and look at the underside. Okay, looking at the bottom, screws missing again, and a foot's missing. It must have been amputated. Oh, that sucked. I better edit that one out. Hey, that's what you get for these videos, You watch my channel, that's the price you're going to pay. So let's remove this cover. And I can tell you, the inside of this thing smells like cigarette smoke when somebody was smoking the cigarette with their butt. It just has that stench that I hate. Gross. Yeah. Okay, the underside doesn't look too bad either. I mean, looking at this, that appears to be all in one piece as well. Okay, well, I guess the question is, does this thing work? Will this thing work? I don't know. It's a really nice amp. I mean, these 2252s are very typical circuit design, nothing special. So, I don't know. Well, let's power it up and give it the old dim bulb test. Okay, I think I have it in here. There's the small 40 watt bulb. Is the only one I have in the circuit right now. Let's turn this on. It got bright and then it dimmed down a little bit, but boy, that is drawing some serious current for just idling. 221 milliamps through that bulb. So that kind of indicates to me, and of course the AM, okay, so at least the low voltage power supply, I mean, you can tell from the lights that you have something. There's some life in this thing. We have panel lamps. But that is a really bright bulb. So let's just stop here. I'll turn the power off. And let's take some measurements. Now the first thing I'm going to do, and there's a couple different approaches that you can take to this. First of all, if it's a completely unknown amplifier like this, you can do what I just did, put a very heavy current limit on it so that you really can't get much current into the amp to fry things, and you can power it up like I did. And if it powers up and the bulb dims down, chances are at least you know there's no shorts. If the bulb stays really bright like that, but not fully bright, then there may be a short somewhere. And you can go forward and check your positive and negative power rails, you know, for the outputs. The other option you could do is you can go into ohms or into diode check, depending on what you want to do here. And you can just measure the output transistors in circuit to see if there's any dead shorts anywhere. Kind of do some static measurements. I typically just kind of bulldoze through it and use the dim bulb method. It's a little faster. You do have a little bit more of a risk of damaging something, but again, I don't worry about that too much because that's a pretty low risk. So let's turn this on. And I'm just set to DC volts, and where these two capacitors go together, that is going to be your ground, or the common point. And then the two outsides, the red wire is usually going to be the positive, and the white wire is going to be the negative rail. And you can usually tell because the capacitors are marked. You either have a plus and minus on the terminals, or you'll have a black dot on the negative terminal of the capacitor, and a no dot or a silver on the positive terminal. So you can see, since the black is going to the common and the silver is going to the power rail, this is going to be your positive supply. In this one, the black is going to the power supply. So it's a negative power supply, and the plus is going to the ground. So you know this is your negative power supply. Most of you know that, but some of you may not. So let's rotate this back around. And I'm going to go from the ground to our negative lead. And you can see I have 19 volts DC there. And if I go to the positive, I should have the same, and I do. So I have a positive 19 and a negative 19. Now what that means, if the voltages match between the two sides, and you have voltages on both sides, then there's a good chance that the power transistors are not shorted. Now there is one caveat to that, and that is on the power transistors, and we'll look at a schematic here in a minute. There are current limiting resistors. They're big ceramic resistors. And I'm speaking in general, most of this era of amplifier. You can see you have these big ceramic resistors. Those are in line with your DC power. So if one of the transistors is shorted, there is also a possibility that one of these transistors blew open and it has gone open circuit. So the transistor is shorted, but the reason it's not loading the power supply down is because it opened this. But typically when that happens, you'll also open one of these fuses somewhere, you know, like a power supply fuse. Just going over basic things that you can, when you're trying to think. And why did I just go directly to the power amplifier? Well, in most cases, any bad problem that will cause a heavy short in the system will typically happen in the main, big power supply for the, for the outputs, and in the power output section of the power amplifier. The smaller things, although they can fail and although they can short, typically they don't. So I always go for the amplifier section first. If I can get that working and everything's good, chances are the rest of it is at least going to function to the point that we can safely test the amp and move forward. Doesn't mean that there's no problem in the preamp or in the tone control or the tuner or whatever, but it means that chances are there's nothing that's going to cause power problems on the main power rails. So this is good news. Now what we can do is we can go to, and I'm trying to reach around the camera here so it's a little awkward. I'm going to go to the ground, and then I'm going to look on the collector, which is the center part of this transistor socket, and you should see your DC rail there, and you do. Let me give you a little better angle here to look at this. So from here to here, and this one should give me the negative rail, and it does. So this is one pair of transistors for the one channel, and the other pair is over here. And then if I go from ground to the emitter, that's going to be this pin. You can see you have about 400 millivolts. So that means the transistor is at least barely turned on. And if I go to the base, you can see there's only about 54, 55 millivolts. So I don't think these transistors are, of course, they're not going to bias quite yet. And this one has 180 millivolts on the emitter, or I mean on the base, and 54 on the emitter. Or am I right? Yeah, I am. Okay. So let me get that straight again. Base has 400 millivolts. Base has 180 millivolts. The emitter on this side, 500 or 54 millivolts. Emitter on this side, 54 millivolts. So these transistors are trying to turn on, but since I don't have enough voltage because of that light bulb that's absorbing most of the power right now, they're not fully turning on. Okay. Now, another thing we can tell, if I have my negative lead of my voltmeter on there and I check the collector of this transistor, notice it's a positive voltage. That means this is going to be the NPN transistor. The other one's going to be a negative voltage, indicating it's the PNP transistor. So this is a complementary amplifier. So it has a positive on one collector and a negative on the other. And that's telling you that it's a complementary amplifier. I haven't even looked at the schematic yet. These are just clues that we can look at and kind of get at least an inkling of what's going on. Okay, if I check the other channel, here's the collector, same thing, and I should get similar voltages. And this one has, look at that, I have negative 16.9 volts, and this side is, okay, that's a shorted transistor. So why do I say that? Well, let's get a schematic now and talk about it. Okay, I downloaded this service manual from hi-fi-engine.com, and I know that if you don't have a current membership to Hi-Fi Engine, I don't think they're taking new memberships, although they might be, I don't know. But you can also go to Electrotanya. There's many different, there's some pay sites and a lot of free sites, and you can always start with the basic Google search of Marantz 2252B service manual and then PDF. So just Google search that and you'll see lots of places to download this usually. And you can find most service manuals from, 1960s, 70s, and 80s vintage audio gear by using that method. Now, here's a schematic of the power amplifier, and it doesn't show the output transistors. They would be connected here, and in order to see that, you would need the full schematic, which I also printed out, and it shows the same thing. It's just kind of smaller print. You can see how they're connected there. And you see where the collector is of the NPN transistor? And this is where your power is coming in. And that's going to be your DC voltage. And see right here, this wire comes off of it. It goes down here, goes around here, goes all the way down here, and it goes to our positive power rail right there. See, there's the positive on the power supply. And then on the PNP transistor, see the PNP has the arrow that points in towards the base. You can see the wire connected to it. And it comes down and around to this wire and goes down here, and it goes to the negative rail. Now, if you notice, they're tied together. So they're all four of the transistors. So the left and the right channels both derive their power from one common power supply. So we know the collector to the emitter is probably not totally shorted on it, or it would take down all four transistors. They would all kind of, or one pair of them would come off, would have a short on it. But since we're getting collector to emitter, or I'm sorry, collector to base shorts, and we're also getting, we're getting our voltage leaking to the base and to the emitter, then one side is shorting. And so that NPN transistor over there on one channel has a short. So what I was doing was I was reading from ground to here, and let's look at a little bit bigger picture. So I was connecting my negative terminal here to the ground, to your common, which is, I have to keep jumping around on you, which is right here, this center tap. And you can see the center tap of your transformer. It goes to this side of the two capacitors where they tie together with the black wires. So I'm putting my black lead there, and I was putting my red lead here and here first to test our DC rails. Then I was going up here and testing again here and here. I was also testing here and here. Now on one channel, when I read the base voltage and the emitter voltage, they were both relatively low, and they're supposed to be. See, like the base is supposed to have about a 0.5 volt on it, and the emitter, they're saying they want 0 pretty much. It's going to be very low, just going to be millivolts. And what we were seeing on one channel, we were getting that, right? But on the other channel, I was reading that voltage that's here. I was reading it here and here. So like everything shorted together on this side and on this side. And since it wasn't pulling the power supply down, chances are we may have an open resistor as well or something going on. So let's see that. Let's see if I'm right. Because you can see where those come in. The emitter comes in on this line here. And you can see it comes back here and it goes through this 0.039 at 5 watts. And then it ties in a common point, and this is what goes out to the speaker. Okay, so this is your speaker terminal, would be right on this line along here. And then it goes through this other resistor here. So it goes through this one, and then it goes to the emitter of the PNP. So you see the two, that's why these are called emitter resistors. And usually when you have a really bad short like that, one of these resistors or both will burn open. So let's see. Okay, I'm now going to take my meter and move it to ohms. And we have those 4 resistors. Let's measure the first one. It's good. See, it's reading about a 0.5 ohm. So you have the 0.39 ohms of the resistor plus the little tiny bit of resistance in the leads themselves for the probes. And that's giving us about a 0.5 ohm. And we look over here, same thing. We check this side. So they may be all good. Good. And this one is good. So the only thing that's wrong is the output transistor is shorted. So we have one shorted transistor. So now let's go in here. Let's go back to voltage. Let's make sure that our power supply is properly discharged. If it's not, we will discharge it. See, I still have 15 volts positive and 15 volts. I have 0 there. So you see how one side stayed charged up? I don't know if you can see that or not. This side stayed charged up pretty good. This side is already bled down, so I already see that's an indication that one of the transistors somewhere is failing somehow, is leaking or shorting. So we need to make it safe. So we're going to use our little stinger cable here. And all this is a resistor. And one end of the resistor goes to this lead that's clipping to ground. The other end of the resistor goes to this metal rod that's insulated. And I can touch it. And it'll just bleed the resistor, or bleed the capacitor through that resistor. And I'll do this side as well, even though it's already discharged. And now it should be safe, and I can measure it again. And you can see it's down to nothing. Okay. So now, let's measure. Okay, so we're in diode mode. And we're going to do our test. So these are the good ones. This channel, they seem to be good. So again, this we determined was the NPN. So the P lead goes onto the base because it's an NPN transistor. I do this in most videos now, so you all get used to it. All right, so if I go from the base to the collector, you can see for a second there it looked like a short, but I'm charging this capacitor here. And you can see I have a voltage drop there. If I go from the base to the emitter, it's going to do it again. And you can see that's reading that resistor in circuit, so you're not going to get a just a junction reading. If we go on to this side, same thing. That one's good. I go to this side, it's that 99 millivolts. Now the whole idea is, this was the good side. You saw the readings. Let's go to the bad side now. And I'm going to assume, but I don't know for sure, but I'm going to guess that this is going to be the NPN transistor. So, and it is. See, I have a voltage drop there. That's good. So believe it or not, that one reads okay. And if I go from emitter to collector, that's good too. I don't see any shorts. You see that? Okay. And this one here is buried underneath these transistors, or under these capacitors. So let's see if I can reach it. It'd help if I could see too. All right. And you can see it's charging up. And if I go to the other side, if I can reach it, let's flip these around. So maybe it is, that one is the NPN instead of the PNP. So let's check that. Yep. Yeah, and see we're checking across there. So how about this other one? And if I get, I don't know if I can get onto the base, or to the base to emitter. Can't reach from there. Can't get in there. Hold on, maybe I can get it from here. Yes, and it's that 99. See? So the transistors actually test good. They're not bad, at least in circuit. So that's kind of strange that the voltages are like that on there. So maybe there is something else shorted that other than the output transistors. I don't know. But I don't see any dead shorts yet, unless one of the driver transistors. So in addition to your outputs, and usually it's the outputs that fail. That's why that's the first thing I tested. I tested the power supplies, and then I tested the outputs. And if those are good, maybe one of these is failing on us. So we can flip the amp around and look at them and see if, and we're just doing some basic testing right now, because I don't want to put full power to this or any additional power to it until I know that all the shorts are gone, you know, any kind of dead short. I'm not so worried about, you know, leaky whatever or something, open circuit or something, but I don't want any shorted circuits. Okay, so let's look up here, and you can see right here are the drivers. These appear to be the drivers right here. So let's go on to base, and again, I don't know if this is PNP or NPN. I'm going to start out as if it's a PNP. So let's look at here to here. Good. Good. And then emitter collector. Okay, no shorts. And this side here was the one that was kind of behaving itself. So this one must be the NPN. And so let's go here to here. That's good. Good. And no shorts. Okay. So that side's good. All right, let's see what we have on this side. That reads a little bit different, doesn't it? See, that reads from, come on. That one reads only about 300 millivolts from base to collector. Let's flip it around here. Maybe this is, maybe I have it on here wrong. No? And you can see on the other side, base to collector was much higher than that. So if I go base to collector here is 0.6, which is what you would expect, and the other way is 2 volts. See that? And base to collector here, 0.6 and 2 volts. So you can see, comparing the two channels, this transistor appears to be faulty or leaky in circuit. And let's do base to collector in here. Oh yeah, that's weirdness. And if I do base to collector this way, yeah, I don't know. Oh, I'm sorry, I was checking emitter collector. Just ignore me. Okay. That's reading good that way. So it appears that this transistor is the bad one. The base is on the top here. The base is on the bottom on this side because the transistors are facing out. So you have to watch the pin out when you're checking these. Yeah. See, 300 millivolts. All the other ones are 600 millivolts. So we have 3 transistors with 600 millivolts roughly between the base and the collector. And how do I know the base and the collector? Well, they actually mark it right on the board there. And if you look down, I hope I can zoom in enough to see it. You see right there where it says collector. So right there is B for base. I don't know if that'll show it. See, base and collector. And on this side, I don't know if I can get you around to see it. And you can see how the E for the emitter, and then this one is the collector and the base. And it's marked behind there. You can see it. So that's how I know the pin out. But you can also just look at the transistor package itself sometimes and figure it out. Because most of these TO202 and TO220, the couple different square type of driver transistors, they are always base collector emitter or emitter collector base. So the collector is the center pin. All right. So this is probably a leaky transistor, and that's why it was turning on that other one full bore. And that's why we were seeing voltage on the output transistor. So the output transistor is probably not bad, and it could be that either this is bad or something connected to it is bad. So we would have to look at the schematics a little bit more. So let's check it out. Okay. So that would be, which one is this on the board? Let me see if I can, that would be Q709. So Q709 would be this PNP transistor down here. And when I read from the base to the collector, so from base to collector, from here to here, this is where I'm reading that strange, the only 300 millivolts. And on the other one, all these other ones, I'm reading 600 millivolts. So this might be a leaky transistor. The other thing, this resistor right here, R755, is probably, they're saying it's 0 ohms. So it might be just a fusible resistor that's in there. So if this little 100 picofarad capacitor shorted out or leaked really bad, that would cause that. That would cause a reduced drop across here. but I highly doubt that because these almost never fail. So chances are all that's wrong here is we have a bad driver transistor. So you see, just using a meter with the volts, the ohms, and the diode check mode, we really haven't done very much, but just by using a little bit of theory of how the amp works and doing some tests, we've somewhat determined that our power supply is mostly working, it seems to be, and that the output transistors are probably good, and that we have Q709 might possibly be a bad transistor. So I can pull this transistor and we can test it more closely to see if it is in fact bad. Another option would be to just check some voltages and compare them. So the complement, or I mean the counterpart to the Q709, so that would be the PNP on this channel, would be this one down here, which is Q708 on this side. So 708 is this one. So these two transistors, if I read the voltages on the 3 pins, they should read the same. So if I look at voltage on, let me see if I can get some better lighting here for you. If I look from ground to each of these 3 pins here, it should be the same voltage as from ground to these 3 pins here, because they're the same circuit. The right and left channel are the same circuit. It's 2 amplifiers, 2 identical amplifiers on one circuit board. That's what gives you your left and right channel. So each one should work the same. So if I turn that on, and I'm going to take this probe and I'm going to just touch it to ground somewhere. So like this chassis right here, for instance, would be ground. So I'm going to turn this on once again, and I'm going to measure from ground right here, and I'm going to go base is almost our full 19 volts, huh? Collector, and emitter. So they all have most of the rail voltage on them. This one, base, I only have 1 volt. See that? Collector, I have the full voltage, which you should have. And the emitter is 400 millivolts, which is what I would expect. Okay, so that transistor is bad. Now here's where things get fun. This is not a very service-friendly amplifier, as you can see. The only way that we can get at that transistor, it's behind these capacitors, is we are going to have to remove these capacitors. And hopefully we can get the screws out, and you can see they're epoxy. You know, they put that thread locker on there, and you kind of just have to get in there and take, there's 1 screw here, 1 here, 1 there, and 1 where the sun don't shine. Okay, as it turns out, it is a 5mm nut. And man, I'll tell you, that glue is nasty. It is really, really nasty. And again, you can try to soften it with your soldering iron and things, but I've never had much luck with these things here. Okay. Now I got to get the other side. Okay, so as it turns out, it is this one, and this one that I need to remove. And again, we're going to go old school because some of you don't have desoldering stations. So we're just going to use some desoldering wick. We can also use a desoldering pump. That's just a matter of what you like. I'm just going to use this. And I'm going to try to do this around the camera. So normally it's a little easier than this, but it's kind of awkward when you're reaching really far around the camera. Okay, there's one. There's two. And then I'll snip that down a little bit. And this should be number 3. Isn't this fun? Not. Oops. There we go. I think I got it. Okay. Yep. Now we have to roll this around. I'll have to take that clamp off of there. So, and that holds, this little clamp here holds this thermistor, which is gluing these two things together. You can see they put that nasty glue on there, the corrosive glue. And you have to be very careful because the leads will break very easily on those. And I can take this off. And of course, now that there's glue on it, we can't see what kind of transistor it is. It's a 2S. Let's look down here. I can't see. 2S B5, what is it? 545 or 945? 2SB, can you see that? 7, no, 5, well, Tony gives up. It is, let's see if they say in here what it is. The big schematic, Q709. If we look over here, Q709 is a 2SB 549. BR549. Okay. Sorry. Some of you may get that. Okay. And I just realized, well, maybe I didn't. Was I on diode check the last time, or was I on continuity check? Who knows? All right, so it goes emitter, collector, base. So the base is here. It is a PNP. So let's see. Can I do this? Let's switch things around to make them a little more visible. I hope you can see. I'm going to have to edit some of this crap out of there for sure. Okay. Now it's not reading bad. How about that? So you can see now that 300 millivolts has gone back up to 600 and so. So it is something in the circuit that is causing that strange reading. So what we want to do is we're going to flip this around and I'm going to check those same leads from the back here without the transistor. And there's your two, there it is. I hate reflections. Look at that. Isn't that crazy? So it's not the transistor. It is something in with the transistor between the base and collector. How about that? We have a good transistor here as far as we know, and something that is leaking between the base and the collector. So now we have to look at the schematic to see what else it could be. All right. So here's the base and the collector. The only thing connected to the collector, as you can see, is this resistor R7, what is it, 755, and they're saying 0 ohms, so that's just a jumper. And let's look on the board if we can find it. Yep, I see it from here. Come on, there we go. R755, and it is just a 0 ohm jumper, so that's just a straight piece of wire. So we know it's not that. The other thing we have is C725, which is that 100 picofarad resistor. And what happens if we measure across that, which is from here to here? What do I have there? 278 ohms. Well, that's not right. That's definitely not right. 723 reads mega ohms. I mean, if I back off here and I read here to here, which is what it should read, it's, you know, mega ohms. See that? 23 mega ohms. But this side, this little capacitor right here, it's 277 ohms. That is wrong. Wrong, wrong, wrong. So let's pull that capacitor. That's very rare you see these ceramic capacitors fail like that. They almost never short like that. So let's pull it and just see for sure if that's what it is. Okay, so after disconnecting the wrong 2 wires, which is a diode, you can see that's there. These 2 leads are the capacitor, and look at that corrosive glue. And I don't know how far I can zoom in without it going out of focus. But take a look at this up here. It looks like something was here at one point in time, because I can see heat, like insulation sleeving of a component here and here. And I see that corrosive glue that is absolutely horrible. And let's see if I can scrape a little bit of that away. I'm wondering if maybe that's part of where our problem is this glue here. Maybe we can clean some of that off. And I could try the different techniques to clean this with, sometimes you can use freeze spray, sometimes you can use alcohol, sometimes you can use a little bit of, what is it, like nail polish remover kind of stuff, acetone, and just clean that. I'm going to try the simplest one. I'm going to try the alcohol. Okay, before I get too aggressive with the cleaning, I just want to make sure my 277 ohms is still there, and it is. Alright, so let's get some of these cotton swabs here. And I'm just going to, I have to get this cleaned off anyway, just so I can bunch of fuzz on there. This is not easy when you can't get close to it because there's a camera in your face, but hey, I want you to have fun too. I mean, what's worse than watching paint peel? Watching dried glue peel. Isn't that fun? Alright. That should be enough that I can get on there with the solder wick and clean it off. Let's see. Isn't this just lovely? I don't like working on this amp. I can just tell you that right now. I don't like it. Okay. Okay, that's ready to pop off. Let me flip this around and get it out. Okay, capacitor is out. Let's get the meter. I really have never seen these really do this, and sure enough, it's open. So that means if I measure that, you're still going to see your 277 ohms. Well, now it's up to 297. Let's keep cleaning this glue. Okay, what I'm not sure about is there is a solder blob right here after cleaning the glue, and it is touching this trace right here. Now, I don't know if these two traces are tied together or not, but I'm going to clean this off and see. Okay, I cleaned it up, and that didn't change anything, so I put the components back in. You can see here and here. And let's go back to the schematic. If we look right here, this is where we're seeing the 277 ohms from the base to the collector. And so from this point to the ground point, or to the common point for all of this, which is going to be your DC rail, that's where I'm seeing that 277 ohms. Now, if we follow this line across here, we can't have any common point between here and here through this. So I'm not going to worry about that. If we follow back here, we have a 33 ohm resistor and Q705, and it goes into the collector. So if we have a collector to emitter short or leak, that could do it. Looking up here, I really don't see any common point for that to get around there. So let's look at the emitter collector of this transistor right here. And probably the lighting was messed up because I have my LED light, and that messes with this camera sometimes, so sorry about that. So Q705 is right here, and there's the emitter, and there's the collector. Let me get you on the camera, and I'm just in ohms right now. If I go from emitter to collector, look at that, 241 ohms. And if I compare it to the other channel, which is Q706, the emitter is here and the collector is here. It should be the same. And it is not. Look at that. K ohms, and it's climbing way up. I wonder if this is bad. That sucks. The reason that sucks is you can't get to any of this. The speaker select switches are on the front here. You see them? You have these two rods that go under the board, and then they come up and connect right here and here. You have all these wires around here and around here and around here, and you would have to to get this board out to where you can get to it, you have to remove all of that to get this module out. So all these wires are going to have to be marked and removed. Everything's going to have to be tested. And unfortunately, that's the way this horribly designed amplifier works. This is a terrible design. It's not service friendly, and it's not really designed to be worked on. A lot of the other ones you've seen, a lot of the other Marantz amplifiers, the older ones, they're a dream to work on. This one completely sucks, and you can see why now. This board is very convoluted, and unfortunately we're going to have to take some wires off to get to it. But it is what it is, and I mean, as much as I hate it, there's nothing else you can do. Now, there's a possibility that if I take some of these bottom wires out, this thing may swing up that way to where I can get to it. I can disconnect these two couplings here and maybe get this to swing up, and just by disconnecting these lower posts down here and get enough room to work. But wow, that's a big if. Let me see what I can do. Okay, so I could barely reach behind here, behind these rods and all this stuff, and probably get to this transistor to remove it and test it. But there's going to be a lot of other work that's going to need to be done. So what I've chosen to do is I am going to remove all these wires, mark them and take lots of pictures, and then remove the whole module so I can work on it, more easily. You can do a lot neater work that way. You're not going to hit wires with your soldering iron and burn the insulation and all that. It's just easier to do. It looks like a daunting task. It is a little bit of a pain in the butt, but really, if you mark everything, there's not as many wires as it first looks like. I mean, you have a row of them here, a row of them there, and a few on this side for the speakers, and one set that goes to the front to some of the jacks on the front. So we can remove those as I lose my voice, and then I can get this out. The sockets for the heatsink are soldered directly to the board also. So again, it makes it very awkward to get at anything on this. And the funny thing is, if you look at the 2232 or 2252, which is the non-B version, it's more traditional, like a Marantz receiver. It has the heat sinks with the outputs over here, but then it has the power amp boards mounted against the heatsink here and here, one for left and one for right channel, and a separate power supply. It's a lot easier to work on than this one. So just remember, if you're going to work on these more later models, like the B series, a lot of times, not just Marantz, but a lot of the manufacturers like Pioneer and some of the others start integrating circuitry onto a board to make it more dense and cut costs. And sometimes that makes it a lot more difficult to service it after it's all been assembled at the factory. Remember, these things are all kind of put together. It's not so hard to put them all together because all the wires are hanging out. They put this module together, they put it in here, and then they wire wrap all the wires on and kind of wire it in. And so you have to kind of reverse the process to take it back out. So anyway, and there's no plugs, so that makes it difficult. So we're going to do that, and you just have to be patient and take your time. And there we go. Now it goes without saying, you want to take a lot of pictures so you know how the wires went, how they were routed, where they were connected, so forth. But in addition to that, what I like to do is I'll take a really fine point permanent marker and I'll just very carefully write the numbers of the terminals when I remove them. It's going to make it a lot easier, and it's kind of surprising how you can take so many pictures, and yet when you get all the wires off and you look at your pictures, you can still sometimes get confused where they go. because for whatever reason you didn't get the photograph at the correct angle or something. So this is just a little extra insurance, and you can't always mark every single wire. Some of them are tiny or whatever, but if you can mark the majority of them, you can really get things back into place a lot quicker. So that's just kind of a thing that I do, and it's just an extra layer of safety that you're going to get things put back together the way they came apart. It seems like every time I do a video on a piece of equipment that has wire wrap, I always get the question in the comments, how do you get the wire wraps off? Well, there's a couple ways to do it. The first one is you can just take a little pair of needle nose pliers and kind of pick at the edge of the wire, and just unwrap it. The other way is just to clip it off. If you have enough extra length, you just cut it off and then strip it and solder it back onto the post. Or you can use one of these wire unwrap tools, and all it is a piece of metal tubing that's hollow. You see, I don't know if it'll focus, and what you do is it just has this little spiral notch at the end of it. I don't know if you can see or not, and it goes over the wire, over the post, and it just goes around and it hooks the wire and just gently unwraps it. That's the best way to deal with it, and that's how I do it. Now, one extra step is, for instance, this one over here. If we look very closely, you can see that it has been, this wire was soldered in the front. So now there's a blob of solder. You really can't get that wire unwrap tool there to get this back one that's wrapped on. So sometimes what you can do is, if you're real careful, you can take some desoldering braid like this, and you can clean it off, and it'll usually absorb most of it off there, and clean it enough. See that? And then you can get the unwrap tool on it, and sometimes you'll luck out just like that. And there we go. And that's how it comes off. So just another little tip how to deal with that. And then to put it back on, if you're careful when you unwrap it, it'll still be spiraled like this, and you can put it back on, and you can use a pair of needle nose pliers to wind it back around. Now, I always follow up with a little drop of solder on it, because it's not going to bite into the standoff the way that it did when it was originally put on. The other thing you could do is strip it back and use new wire, use a wire wrap tool and wrap it back on the correct way. And but really, you're okay just winding it back on, tightening it up with your pliers, and then putting a drop of solder on it. Okay, and once the front wires are all disconnected, and a couple of them, it was just a lot easier to take some tape and mark the number of the post on the tape, and then stick it on the wire when you remove it. And last but not least, you have to remove the power leads and the ground leads. And there's one ground that's on a ring terminal up here, and then two that go to the amplifier, and you can see them down here. And you're going to have to heat this up and take it off, or you could cut it, but I'm going to try to do it this way if I can. And for those of you who said that these things are useless today and for old-fashioned things, well, have fun with your soldering pencil. All I can tell you. Yeah. Yeah, use your little USB soldering pencil on this. Let me know how that goes for you. Okay. Kind of awkward with the camera rolling, but we'll let the camera roll and do this real time. If you can get it heated up enough, you can take the iron away. There we go. There's one. And then we'll get this other one. I'm trying not to melt the capacitors too much. Even Tony tracks on there, huh? What are you going to do? All right. And that's it. So it's all out, and we should be able to remove this now if we flip it around. Let me move some things out of the way, including my light. And there it is. And like I said, a couple of the wires, the real thin ones, it was just easier to mark them with tape. And that's what it takes to get this thing apart. I mean, it's going to take you about 20 minutes to half an hour to do all that if you take your time and mark everything. And if you go too fast, don't be surprised if you forget to take a picture or to mark a wire, and then it's going to take you twice as long to go through the schematics and figure out how to hook it back up later. So a little extra time now saves you a lot of time later. So what was the point in taking this whole thing apart in the first place, if we haven't already forgotten? Well, we really need to get this transistor out, this Q705, to test it, because if you recall, it appeared to be leaky. So let's see if that is the case. Or should I say it appeared leaky, to freak out all you grammar nannies. I know how wigged out you get over that. You and my sister. My sister's an attorney, and, you know, for her whole life she's been trying to correct my grammar, which makes me dig my heels in even more and use improper grammar. I quite enjoy that. It's a bit of a sport. So feel free to try to correct me. It's not going to work. Okay. And like I said, we can use all the expensive desoldering stations and things, but I think the purpose of this video is to try to be minimalist if we can. Now, I will, in later parts of this video, or of this series, we'll show different test equipment, but we're going to see if we can just troubleshoot this whole thing and get it working, at least, with just a multimeter. And then we'll look at what we do just with a oscilloscope and with a signal generator. And I'm going to try to just stick to those three things. Of course, if you have to do tuner alignment and things, you're going to have to get into more equipment than that. That's just the reality of it. But nevertheless, we're going to do what we can with minimum. All right, so I think this is... What was this? Was this a PNP or an NPN? This was an NPN, so I want to... Here's the base. I just want to see what we've got here. And it's reading correctly like this, and if I put my meter onto ohms and look from the collector emitter, and of course there's no leakage between collector emitter now that we've taken it out. But the good news is, oh, and what else did I say? Base collector? Let's see. No. Oh yeah, it is reading a little bit. Not like it was. And you're not seeing a damn thing, are you? Because I, once again, do not have the meter in plain view. Cameras are a pain in the butt. You got to keep moving them around. Okay. So here's... See, it's mega ohms, though. It's not 100 ohms, you know. So there's something else in this circuit where we're seeing that leakage. And it's not the transistor. So let's... Oh. Did you see what I did? Did you all see what I did? I took out the wrong transistor. That's the one that was not reading bad. Thank you. Let's put it back in. I'm not going to edit this out because I find these sorts of things quite amusing. This is, you know, you've seen this in other videos I've done. So I think it's kind of become a trademark of my videos where I remove the wrong component because I'm not paying attention. Okay, so we'll pop that back in real quick. All right, let's take the other one out. Let's make sure we get the correct one this time. It's these three right here. All right, so let's try it once again. Or one more once, as we may say. Okay, now let's see how this one reads. First, we will do we'll use the, I don't know if you can see all this here. Can you see the meter? All right, so, and see already it reads funny. If we go from the base to the collector, it's hard for me to do this around the camera and still keep things in view for you, but base to collector, see how it's only about 460 millivolts? And see that one's only 200 millivolts. Now if I flip it around, it's reading in both directions. See that? This is a leaky transistor. It's bad. Now, I just want to show you something. We're not going to use this as troubleshooting tool because we know it's bad, but what if we put it in one of these cheap, you know, $10 eBay testers? What would it do? It's not happy. Bueller. There you go. Bad transistor. And we found it just by checking voltages and continuity through the circuit. So there you go. Our guess was correct. That's what it was, and it was not an output. Now here's the thing. The tendency would be when you see that excessive voltage on the output transistors would be to just shotgun it and replace the outputs. But as you can see, they're not bad. It was this transistor. It wasn't the driver transistors either. It was the pre-driver. Okay, I have an old NTE manual here. And of course you can do the old Google search thing or whatever, but since I had this, I just thought I would take a chance and see if the 1885 is listed, and sure enough it is. And they're saying that that translates over to an NTE 399. Now, not a lot of you, or some of you, get hung up on NTE components because they're not always exact replacement, blah, yada, yada, yada. But the truth of the matter is, they're damn close most of the time. And it will at least give you an idea of the type of transistor this is. Now, we can, again, look up an original 2SC 1885 online if we want to. But I think this is going to just give us enough information to move along with the project. So let's look up an NTE 399. I'm just going to go in the transistor section. And they're saying that a 399 is an NPN silicon high voltage amp video giant TO92, which is that this is a TO92L, in other words. A regular TO92 is about half the height of this. These ones usually can dissipate more heat than an original, than the shorter one. So if we look at the voltages On the NTEs, at least, they're good for 100 milliamps, which, like KSC 1845s and so forth, those are going to be like 50 milliamps. So this is double that. These are 300 volt VB or VCBO and VCEO. So the breakdown voltages are very high on this transistor. Forward current gain is 100 minimum, so it's going to be in that 100 to 200 range. And it's a 0.9 watt transistor. So the voltage is going to be an issue, but remember, this amplifier, the power supplies, don't go over 45 volts. And even if you did the differential between the plus 45 and minus 45, that's still only a 90 volt difference. So really, a transistor, you don't need these 300 volt ratings. But the rest of this, it's a 50 megahertz. I think I may have a suitable replacement for this. So you can see I have these KSC 2383s. The pinout is exactly the same, emitter-based collector. They are, in fact, the TO92L package. But instead of 300 volts, they have a 160 volt breakdown voltage. And instead of 100 milliamps, they're rated at 1 amp. So they have a lot higher current capability. And I happen to know from the data sheets, because I've worked with these a lot, they have that gain range somewhere in the 120 to 150, which is right the same what this one is. And their frequency, the FT transition frequency is very similar. So this is a good substitute for this particular application. No, it's half the voltage. It's instead of 300 volts, it's 160. But again, as we said, in this application, I think these would actually be a better fit than these ones. So, I think we're actually improving things. So I'm going to replace both of them, on both channels so they match. But there you go. Okay, the transistors have been replaced. I cleaned off most of that corrosive glue and kind of cleaned up some of the flux. Everything's put back together. Now, at this point, what I would normally do is I would use my dual power supply, which is up here. You can see it right there. I usually use this one. And I would apply plus and minus 30 volts with some current limiting on it. And I would measure to see if the amplifier is functioning. In this case, we don't have that. Remember, our rule is we're only going to use our meter in this video. So I'm going to just connect with some jumper leads to the main DC power supply. Now, a couple things with this amplifier. You need to look at schematics if you're going to do this. You can see here's the power transformer right here. And there are 3 different sets of windings here. There's this winding, which is for your split rail power supply. And the whole purpose of this big power supply, which is those big capacitors in the back, is to power the power amplifier. The whole power amplifier gets its power just from that. These other ones go onto the same board, and they are for the low voltage regulated power supplies that feed the preamp and the phono stage and the tuner and the lights and all the other things, which we don't need that to test this amplifier. We only need this one. And that's good news because really there's only 3 connections that we have to make this amplifier come to life. If you look on the capacitor in the back, you have your negative rail, your positive rail, and your common in the middle, or ground, however you want to call it. And those other 2 windings, if I back up a little bit, they're not connected. So I just taped them off so that they don't short out on anything. We don't need those because we don't need the voltages from those power supplies to test the amplifier. Now, when I turn this on, I'm going to be very careful. Number one, I don't want to short anything out. And you see I put a little piece of masking tape over the two power leads. And I don't want, if something does go wrong, I don't want anything to burn up. So I am going to just use a 40-watt dim bulb tester. So I'm going to put the current limiting bulb in circuit. And that's all I have is this one. And let's turn this on so that when I turn the power on, if something goes wrong, that's not going to go on bright white. Now, if we fixed the amplifier and we found the problem and we took care of it, then my guess is that that bulb will light up bright as the caps charge, those big capacitors charge, and then it'll dim way down, which is what it should do. If it stays really bright like it was, then we still have an additional problem. So let's turn the power on and see what happens. How about that? And it goes totally dim. That's what it should have done. So we fixed it. Now we can go and use our meter, because there is power on there right now. But since there's so tiny amount of current, the light bulb is not lighting up. So let's go to our voltage tests. And let's back this all up so you can see it. And I'll try to stay out of the way of the camera. And I'm going to just use this as our ground, because it's our common point. And there's probably about plus and minus 30 or 40 volts there now. So let's just look at the collectors again. Plus 38, minus 38, and these are all going to be plus and minus 38. All right, let's look at the bases of the transistors. I think this is the base, I believe. Half a volt, half a volt, 0.38, and these all have to do with the bias settings, might be off a little bit. Good. And then let's look at the emitters. And again, about a half a volt. And these are all sitting at idle right now. Okay. So, bottom line is, amplifier is working. Now, of course, we need to adjust the bias and the offset and everything. And we don't have full power on it yet and all that sort of thing, but it's working. So now we can be fairly confident that we don't have to do any more troubleshooting. And we can check our voltages now on those two transistors. And by the way, I did put a new transistor on the other side too, so because you know my rule. So there's 38. 1 volt, and 38. 38, and it's negative 38 by the way. A little bit less, see that? So what that's telling me is that the bias setting on this is a little bit lower than on this side. You know, or one of the transistors has a little bit lower gain somewhere in the circuit, and since everything's not got full current and full power to it, it's not completely turned on and biased properly yet. Either way, it doesn't matter, it's going to work. So our problem is solved, we fixed it, and I'm going to tell you right now, before I go and try to put it all back together, I'm going to do the maintenance on this. We're going to recap it. We're going to service the power supply and do all that, because this is such a pain to take out and put back in. I want to make sure first try when I plug this in, I want it to totally work and not have to take this back out ever again because of how much work there is involved in doing this. Well, we now have a working amplifier module. So I think what we're going to do is we're going to call this one part 1, and I'm going to part 2, we're going to go ahead and I have all the parts out already. We're going to do the recap and the relay, and maybe we'll make that video a soldering chat. Something to do. All right, so until next time, I wish you all peace, joy, happiness, and good health in your lives. And if you like videos where we kind of focus on one piece of test equipment or something like that, or you have any ideas to that effect, let me know down in the comments section. Take care, everybody. We'll see you next time.